Hey everybody, today we are going to be looking at two sections. We're going to start with 5.3, which we're going to talk about medians of triangles. So the first thing that we're going to look at is what is a median, all right? A median is a segment that connects the vertex of a triangle with the midpoint of the opposite side, all right? So we're going to go vertex to midpoint, and that is always a median. Again, there are three in every triangle. So like if we look at this picture right here, we can see BZ is a median because Z is a midpoint. We can see X is a midpoint. We can see Y is a midpoint. So all of these segments are medians. This point right here, we have another point of concurrency. So remember that point of concurrency is where those segments meet. And this point of concurrency is called the centroid. Fun fact about a centroid is it is the balancing point of a triangle. So if you were to cut a triangle out of something a little more substantial like cardstock or cardboard, if you find that centroid, you can balance the triangle on the tip of your pencil. So just a little fun fact for you. So when we're looking at what the centroid means, what it means to be a centroid, is the centroid is going to be 2/3 of this distance. So I know that from B to P is going to be 2/3 of the whole length of B to Z. All right. So I'm going to give you kind of a little bit of a shortcut for this, but we'll look at that in just a second. Okay. So let's take a look. Here I am told that if SP is 16, I want to know the length of SM. Now, there's two ways that I can do this. All right, I know that SP is 2/3 of SM. All right, that's what our theorem right back here just said, is that from the vertex to the centroid is 2/3 the length of the median. All right, so I could get here, I could do 16 equals 2/3 of SM. Then I could multiply both sides by 3/2. And then I'm going to get, okay, so when I do 16 divided by 2, that is 8. And then when I do 8 times 3, that is going to be 24. So 24 is going to be the length of SM. This is one way that I can do it. The other way that we're going to talk about is, for just a minute, let's think about fraction bars. Okay, if I divide this into thirds, and we're going to pretend that these are pretty thirds. Okay, I know that from S to P is 2/3. So that means that P to M has to be 1/3. Okay, so what I want to look at is what is the relationship between SP and SM? Well, SP is twice as big as SM, or SM is half the length of SP. So what I could do is I could say, well, I know that PM is half of SP, so PM is 8, because half of 16 is 8. Then I can add these pieces together. So then SM is going to be 16 plus 8, which is 24. Okay? Either way, you are welcome to do this whatever way you would like to. I like to go, oh, okay, this is 16, that makes this 8, so I'm going to add them together. That's me personally. But you can say, all right, I know that it's 2/3 the whole thing, and set it up this way. Either way, no big deal. Whatever you choose, whatever you like. All right, let's look at the next one. I know that LP is 9. So if LP here is 9, I want to know the length of LT. So now this is the midpoint to the centroid. So this is my 1/3 piece. So again, if we look at it in terms of the theorem, I can say I know that LP is 1/3 the length of LT. LP is 9. and I'm going to multiply both sides by 3 to get that 27 is LT. All right? Or I could say, look, I know that LP is going to be half of PT. Or if I do even easier, 2 times LP is going to be PT. All right? So if I do 2 times 9, I know that this piece is 18. And do you have to write all of this out? Absolutely not. You can just mark the 18 on your picture, and I'm okay with that. We're going to write it out for now, but you don't have to when you're doing your work, okay? So then to get LT, I'm going to add 9 plus 18. That was not a 9. That was special. 9 plus 18. That was very weird. Okay, so then that gives me LT is 27. Either way, again, you can do it with the theorem, which you would need to write out, or you can say, all right, if this is 9, it's my shorter piece. I'm going to double it to get 18, then I'm going to add them together. And again, a lot of that, like this would be the part that I would want you to write out. Just this little piece right here. You wouldn't really need to write this. That would be fine. All right, for part C, I'm told that RN, so this whole segment here, is 33. All right, I want to know what PN is. Well, PN is the 1/3 section. Okay, so I know that PN, because it's coming from the midpoint, all right? Midpoint to centroid is 1/3 of the whole thing. So it's going to be 1/3 of the whole segment. So PN is going to be 1/3 of 33. So PN is going to equal 11. That is the easiest way to do this one, is to say, all right, I'm going to take 33, I'm going to divide it by 3 to get that this is 11, which would make this piece up here 22. Again, I can either double this or subtract it from the 33. But when I see here, these are going to add to 33. So if I wanted RP instead of PN, I would still find PN first. It's just easier. Go, all right, I'm going to divide this by 3 and then multiply it by 2 to get this piece. All right. If you have any questions, please make note of them in your notes now. All right. For our next one, we want to show, we have a plan for a piece of a mobile, which are the things that like hang above baby cribs or decorations and things like that. So we want to know, if we're sculpting a mobile, where do we attach the support so that the triangle is balanced? Well, remember what I was saying at the beginning is that balancing point is the centroid. All right, so we want to find where the centroid is. So in order to do that, I need to first find the midpoint of each side. So I can do this one of 2 ways. I can absolutely do the midpoint formulas. All right. But because I'm on a graph, I can also kind of cheat this a little bit and make it easier. I see that this height here is 4. All right. So from P to R, my vertical change is 4. So if I go 2, I know that this point right here is my midpoint. Let's check it. All right. So if I'm looking at the midpoint for RP, all right, I'm going to add those x's, which is going to be 6 plus 3. I'm going to divide by 2. And then I'm going to add my y's, which is going to be 4 plus 0, divide by 2. All right. 6 plus 3 is going to be 9. 4 plus 0 is 4. So this is going to give me that my midpoint is, and we're going to go ahead and convert it to a decimal for sake of graphing because it's easier to do it that way. We're going to do 4.52. So if I go over 4.5, I go up 2, that's this point right here. Again, when you're on a graph at this point, you are welcome to do this either way. So let's do this one, all right? I see that my vertical change here is 8. So if I go up to 4, this is going to be a midpoint. All right, so if we double check the midpoint of QP, adding my x's is going to be 0 and 3. Whoop. And divide that by 2. And then I'm going to add my y's, which is going to be 8 and 0. And then we're going to divide that by 2. Okay, 0 plus 3 is 3. 8 plus 0 is 8. Okay, again, just for sake of graphing, normally we would just leave this alone. But since we're actually putting it on a graph, we're going to go ahead and take it to a decimal. Oop, I wrote a 0 here. That was silly. Okay, so 8 divided by 2 is 4. 3 divided by 2 is 1.5. So if I go over 1.5, up 4, that's this point. Okay, my third one, I have a vertical change of 4. So if I go up the half distance, so up 2 from point R, this is going to be my midpoint. So again, let's check it. The midpoint of QR. I'm going to add my x's, so 0 plus 6 divide by 2. Add my y's, 8 plus 4, divide by 2. Okay, 0 plus 6 is 6. 8 plus 4 is 12. So 6 divided by 2 is 3. 12 divided by 2 is 6. So if just plotting them over here doesn't make sense to you, just use the midpoint formula. It's fine. Don't worry about that. Okay, don't let one method or the other mess you up. But if you can go, oh, hey, look, I know that this change is 8. So if I go half of that, I'm going to hit my midpoint on the horizontal. That's fine. It's totally up to you. Midpoint formula always works. All right. So now I have my midpoints. So what I'm going to do here next is I'm going to graph my medians. So I'm going to go from the midpoint I found to the vertex on the opposite side. Okay. From the midpoint I found to the vertex on the opposite side. Actually, I'm going to bump the thickness up here a little bit. Okay, and then our last one from our vertex to the vertex, or from our midpoint to the vertex on the opposite side. So right here is where all 3 medians meet. So our centroid has the coordinates over 3, up 4. So if they place the support at the point 3, 4, then the mobile will be balanced. All right. Again, if you have any questions on that, please go ahead and write them down. Okay, so next we're going to look at section 5.4, which is going to talk about midsegments of triangles. So this is our last segment that we're going to look at within this particular chapter. So we have looked at angle bisectors, perpendicular bisectors, medians, and then last but not least, we're going to be looking at midsegments. Okay, a midsegment is a segment that connects midpoints. All right, so a midsegment sounds kind of exactly like what it should. A midsegment is a segment that connects midpoints. So here we can see that X, Y, and Z are all midpoints because the pieces on either side are congruent. And when I connect those midpoints, these are called midsegments. And then triangle XYZ is going to be called a midsegment triangle. Now, what we know about midsegments is that my midsegment is going to be parallel to the side that it does not touch. So these two sides are parallel. And this is also half the length of this. So if I were to look at this and I go, okay, if I say I'm going to take this length right here And now notice it's not really lying on top very well, so this might not be as perfect as I'd like it to be. But if I take those two lengths and I look at this length, and I think I made that a little bit long. So let me fix that just a little bit real quick. So if I look here, all right, that's the length of my parallel side, and then this is my midsegment. So you can see that 2 of the midsegment is going to equal the length of that parallel side. All right, so I can do 2 of these is equal to this. And so what I want you to make a note of in your notes right now is kind of an easier way that I do this, and I say it's going to be 2 times the midsegment is going to equal the other side. Okay? Because I think it's always easier to double the midsegment than it is to cut this in half, because then you're dealing with fractions and all that kind of stuff. All right, so let's take a look at how this works. I want to find the length of UW. So when I look here, UW is this side right here. Actually, let's use a different color. Okay, so this is UW right here. It is going to go with this side here. Okay, ST is going to be its parallel side. So these are my sides that have a relationship. All right. So I know that ST is 7.4. Okay, UW is half of this length. All right, so UW is going to be half of ST. So UW is going to be half of 7.4. So that is going to make UW be 3.7. And then I want to show you guys something. So if this is a midpoint, I know that this is 3.7, this is 3.7, and then we just found this was 3.7. So all 3 of these pieces are all the same. That's true always. All right. Now, the next I want to find the measure of angle SVU. So angle SVU is right here. Okay. And we know that this angle up here is 41 degrees. So what I want you to see is we've got U, W, V, and S, right? I know these sides are parallel. Well, if this is 41 degrees here, we have alternate interior angles here. All right, so these are both going to be 41 degrees. So that means that the measure of angle SVU is 41 degrees. Okay, so again, that's because angle SVU and angle WUV are alternate interior angles. So they are congruent. All right, so we're going to be looking at finding alternate interior angles, and we're also going to be looking at corresponding, or we're going to be looking at same side interiors. So like if this one is 41, I know that this line is also parallel to this line. So that makes this angle 41 degrees. Well, these are corresponding, so this is 41 degrees. All right, I know these are same side interiors, so they're going to add to 180, so that makes this 139 degrees. So there's all kinds of things that we can do when we're looking for angle measures using those parallel lines. Okay? So if you have any questions, again, please write that down. And let's take a look at example 4. All right, I want to find the values of x and y. So again, we're going to look at the fact that we've got mid-segments here, and let's find the pieces that go together. All right, I see MN is X, and it's going to go with this piece right here. All right, I see that Y is OM, and it's going to go with this piece here. And then I have this piece over here, which is going to go with ON. So what I want to do is I want to see which pieces go together, all right? Which ones actually have things that will help me. So I notice that with the greens, there's nothing here, which means I'm not going to use this. This is what we call extraneous information. I don't need it. All right, right here on OM, this is my only Y, which means I need X first. So if I look here, I have an X in my pink and an X up here with these pinks. So my mid-segment, all right, I'm going to double my mid-segment. So remember, we're going to do 2 times that mid-segment is equal to the side. So I'm going to do 2 times X is equal to 4X minus 10. I'm going to subtract 4X from both sides and get negative 2X over here equals negative 10. Divide both sides by negative 2. I'm going to get that X is equal to 5. So then what that's going to mean is I'm going to plug X in over here. This is 2 times 5 plus 12. 2 times 5 is 10. 10 plus 12 is 22. So now I can do the Y's. I can say 2 times Y is equal to 22. Divide both sides by 2. I get Y is 11. Okay, I also am more than welcome to say Y is half of 22. It's whatever is easier for you at the time. When they're equations, it's usually easier to double your mid-segment. When you have a number over here, sometimes this is easier. Again, it is totally up to you whether you want to say it's double the mid-segment equals the side, or we can say that the mid-segment is half the side. Either way, they're both perfectly accurate. It's just taking this, dividing both sides by 2, or taking this and multiplying both sides by 2. They're perfectly equivalent. So sometimes situation by situation, you may change it based on whatever works for the problem best. So we have found here X and Y. All right, so if you have any questions, go ahead and write those down. Now, I would like for you to please pause your video and go ahead and give these 3 a try. All right, go ahead and check your answers. All right, I know that I have mid-segments here. So if I look at JL, JL is going to be twice the length of my mid-segment. My mid-segment's 36, so I multiply it by 2. PM, I have the length of the side, so I can just cut this in half and divide, or I can cut this in half and get that PM is 48.5. All right, these 2 angles here are corresponding angles, so they are congruent. So this angle is going to be 102. All right, if you have any questions on that, please write them down, and then we will go over any questions that you have in class. Please make sure that you do ask me your questions, and I will see you guys later. I hope you have a wonderful day. Bye.